Download this code from codegive.com, link in the description below. Creating your own GPS tracking system that operates 24/7 can be an exciting project. This tutorial will walk you through the process using a combination of hardware, like a GPS module, software, like Python for data processing, and a database for storage. Overview of the system. The system will consist of one GPS module, to capture geographical location. 2 microcontroller, to process the GPS data and send it to a server. 3 server, to receive and store the GPS data. 4 database, to save historical data for retrieval. 5 web interface, to visualize the data. Components required. Hardware. GPS module, like Neo 6M. Microcontroller, like Arduino or Raspberry Pi. Wi-Fi module, like ESP8266 for Arduino or use Raspberry Pi's built-in Wi-Fi. Software. Python, for server-side processing. Flask, for web server. SQLite or MySQL, for database. Step-by-step tutorial. Step 1, setting up the hardware. 1. Connect the GPS module. Connect the GPS module to your microcontroller. For Arduino, you can use TX and RX pins to communicate with the GPS module. 2. Connect the Wi-Fi module, if using Arduino. Connect the ESP8266 module to your Arduino for internet connectivity. Step 2, microcontroller code. Here's an example code for an Arduino that reads GPS data and sends it to a server. Step 3, setting up the server. Use Python with Flask to create a simple server that accepts GPS coordinates. Create a file named appy. Step 4, running the server. Run your Flask server. Step 5, database setup. The database should now be set up with a table location that stores latitude and longitude data. You can use SQLite for simplicity, but you can also opt for MySQL if you need a more robust solution. Step 6, visualizing the data. To visualize the data, you can create a simple HTML page that queries the database and displays the GPS points on a map. You can use Google Maps API or Leaflet.js for this. Example code to fetch data from the database. Conclusion. With this setup, you now have a basic GPS tracking system that can run 24/7. You can enhance the system by adding features like authentication, real-time tracking on a map, notifications, etc. Next steps. Enhance data security, implement HTTPS for secure data transmission. User interface, create a user-friendly web interface for tracking. Data analytics, use data analysis techniques to derive insights from the collected GPS data. This project can be expanded in numerous ways, depending on your specific needs and interests. Happy coding!